Lowering flaps lowers the trailing edge of the wing, as shown in this picture. The wing's lift is increased in two ways. First, the lower trailing edge increases the angle the chord line makes with the relative wind. Greater lift results from this increased angle of attack. Second, the lower trailing edge increases the curvature part of the wing, resulting in increased air velocity over the wing's upper surface. Many flaps even increase the wing's surface area by extending downward and outward, as the Cessna 172 do. Because of the larger angle of attack and greater curvature, flaps provide you with more lift for a given airspeed. What's the reason for putting flaps on small airplanes? First and foremost, they create the lift necessary to maintain flight at slower airspeeds. When landing, your goal is to approach it and touch down at a reasonably slow speed. You certainly don't want to touch down at cruise speed. Such a high-speed landing may make you turn your tires into 3 little puffs of smoke. Flaps allow you to approach and land at a slower speed while maintaining a safe margin above the stall speed. A slower speed on touchdown means less runway is used to stop. This is important considering if the runway is short. Alternately, if the wind is gusty, you may consider approaching with little or no flaps extension. At the slower speeds allowed by flaps, the airplane becomes more difficult to control because the controls are not as responsive. Let's see how effectively the flaps increase lift by referring to the airspeed indicator, as shown in this picture. This picture shows flap speed range. A. Flaps extended, 53 knots, beginning of the white arc. B. No flaps, 60 knots, beginning of green arc. The beginning of the white arc is known as the power-off full stop stalling speed, and non-accelerated flight at the airplane's maximum allowable weight. It's the speed at which the airplane stalls with flaps fully extended, power off, and the gear extended. In this picture, the airplane will fly 53 knots of wind blows over the wings if they are below their critical angle of attack. The high speed end of the white arc is the maximum speed you can fly with flaps fully extended. Flying beyond this speed can damage the flaps. In this example, you wouldn't want the airspeed indicator to indicate more than 107 knots with the flaps extended. Some airplanes, however, allow you to fly at a higher speed with partial flaps extended. Bringing broken or bent airplanes back from a flight isn't a good thing, even if they are rentals. You'll find out how bad of an idea this is when you get a bill for unbending the metal. Notice that the white arc B begins at a speed 7 knots slower than the green arc A. In an earlier discussion, we learned that the green arc is the power-off stalling speed, which gear retracted to. This airplane must have 60 knots or more of wind flowing over the wings to fly with flaps retracted. With flaps fully extended, you can touch down at a slower speed, 7 knots slower to be exact. The full flap stall speed on the airspeed indicator assumes the airplane is flying at the maximum allowable weight. You don't get something for nothing. Flaps provide you with lift, but they also produce drag. Full flaps create a low-speed wing. Try to accelerate it at some point. Drag defeats your efforts. Fortunately, the first half of flap travel usually provides more lift than drag. The last half usually provides more drag than lift. This is why some aircraft manuals recommend only 10 to 25 degrees for flaps for takeoff on short fields, usually 1 or 2 notches on a 3 to 4 notch metal flap system. If you're too high while on approach to land, you can still select full flaps to increase the airplane's drag. It's common to use flaps only when descending within the traffic pattern and not to use when descending from cruise flight. After all, cruise flight descents are efficient and fast at higher speeds, where the drag is greater. If you wanted to descend with flaps from cruise flight, you'd have to slow the airplane down below maximum flap extension speed, the top of the white arc, before applying flaps. This would be cumbersome. The airplane can descend faster at cruise speed with a reduced power while getting you to your destination sooner. Since flaps provide more lift at slower speeds, think carefully about how and when they are retracted when airborne. If you're making a full flap approach and it's necessary to go around, that is, give up this approach, climb, and return for another landing attempt, don't retract the flaps all at once. This would be like having someone remove a part of your wing at a slow speed. The sudden and often dramatic increase in stall speed could place you near a stall before you can accelerate to a safer speed. Apply full power first, then retract the flaps in increments. In airplanes with 30 to 40 degrees of flap extension, retract the flaps to their least drag maximum lift position. Usually this position is found at 1/2 flap travel, depending on the airplane. In airplanes with 3 notches of manual applied flaps, retract 1 notch first, followed by the other 2, once the airplane begins to accelerate. Landing using flaps. You can apply flaps using the flap handle as shown in this picture, or by pressing the F7 key. You can retract them by pressing F6. Since flaps alter the lift and drag characteristics of the wing, be ready to adjust the pitch and maintain the airspeed you want. Applying full flaps creates a lot of drag. Flap application also causes the airplane to pitch up, requiring forward pressure on the joystick to maintain your airspeed. Here's how the process might go if you're too high and need to add flaps to compensate. Since the full flap stalling speed for the airplane is 40 knots, that's where the white arc begins on the airspeed indicator, you'll want to approach at a slightly slower speed. Remember, pilots use an approach speed that's 30% above the stall speed for the airplane's present configuration. For this situation, let's use 60 knots. While approaching without flaps at 65 knots, let's assume we notice that the runway is disappearing below the top of the airplane's panel as shown in this picture. This is one cue that you're going to be too high on the approach. Now is the time to add flaps, or more flaps. You'll press F7 once to lower 10 degrees of flaps. You'll also have to apply a little forward pressure to correct the flap indicated pitch up. And then readjust the pitch for a final approach speed of 53 knots. Don't forget to trim. You'll apply the other 20 degrees of flaps in 10 degrees increments by pressing F7 2 more times until 30 degrees of flaps are extended. That's full flaps for this airplane. As you press F7, be sure to adjust the pitch for 60 knots of airspeed. If flap usage is sufficient, you'll notice that the runway stops disappearing underneath the airplane. The airplane is also pitched forward a bit, allowing a better runway view. The descent rate will also be increased, and the airplane will fly at slightly less of a nose-up pitch as a result of flap application. This is, with flap application, the nose gear isn't as far above the main gear, an additional resource for the flare, as shown in this picture. One of the first things you're sure to notice when using flaps is that the rate of descent is higher. That's why the flare needs to happen a little faster when using flaps. When you're at flare height, raise the nose from its present altitude to about 14 degrees nose-up pitch. Hold that attitude until touchdown. Yes, you may hear the stall horn. More on this in the stall section. As you touch down, but that's okay since you're just inches above the ground. So why use flaps? They allow you to touch down at a slower speed, which means the airplane needs to dissipate less energy while stopping. Additionally, flaps come in handy when you're too high on approaches. They also are useful when landing over an obstacle, or when landing on a short runway. This ground school lesson completes your basic student pilot's training. Once we complete 2 interactive lessons on landings, you're going to solo. Then you're ready to move on to the private pilot lessons. So be prepared to wander the skies alone in search of new adventures.